Hello everybody and welcome back. In this video we're going to take out this makeshift controller that I basically built just for the purpose, and we're going to replace it by its nice sibling, which has the same function, but it is no longer on perf board, but it's a really nice PCB. And it has all the connections that we need, and it's basically all the same, but it is the upgraded version. And I'm going to take the chance and show you once again why I'm going through all the length of changing all of this, and why I'm not just simply sticking with the one that was in there. Now, this whole thing came to be because my chiller actually has a problem with this little valve here. This valve is basically located at the output of the compressor before it goes back into the condenser. And this is a hot side bypass which goes directly into the evaporator. And this is there so when the thermostat decides that you're really close to your target temperature, but the compressor hasn't run for a sufficiently long time, it can actually decide to keep the compressor running in order to lengthen its life, and basically just sends the hot gas right through the evaporator, and thereby sending a lot of lubricant and everything back into the compressor. So this isn't all a bad thing, it's just a waste of energy in some situations, and especially in my situation, because this valve here appears to be slightly faulty. When this thing kicks in, there is almost no residual cooling. So once it kicks in, the compressor is likely to run almost forever. What I did was I basically came up with a slightly improved thermostat that doesn't only take the temperatures on the outside and inside into play, but also the development of the temperature over time. So it does have several modes that allows it to end the bypass mode and go into a mode where it turns off the compressor, and this works really well. I've been using my makeshift contraption for over a week now, and I've done a lot of work, and it adapts to the changes inside the cooling and the warming up of the whole cooler setup very well. And yeah, so that's why I've decided to not change anything anymore, but basically install a slightly more pretty and not that hacked up version of my controller, and yeah, make this a permanent solution. So let's rip out the old one and put the new one in. So this was the original updated thermostat. It basically consists of an Arduino Nano, a small power supply, some capacitors, and a display module. All of the connections were done with wires and clamps, and it was just very simple. The upgraded version is basically all the same. It's just a little bit nicer. So here we have the new thermostat all hooked up, and the controllers, well, the controllers for the relays are over here, and basically the standard wiring for the NTCs stays the same. I'm using the same power supply that is already in the chiller, and yeah, it's basically the controller, the thermostat, and the relay board are basically a drop-in replacement, which makes it really cool. And yeah, so it's all hooked up. I'm gonna put a dab of hot melt on here just to hold it in place. It is held in place by a small groove at the bottom, so it can't really come out. You need to angle it up, and then it's unlocked and you can get it out. But now it is pretty much firm in place. There's an opening at the front, so you can connect a computer, and that computer can read the temperature curve from the two sensors in the water reservoir and in the inside of the chiller. And those two sensors are also used to make sure that the water remains at the right temperature and that the inside of the chiller doesn't overheat. Here's another view from the back of the machine, and as you can see, these are the wires that would usually go to the compressor and the bypass valve, and I've added a third connection, and that one is for the fan. So I actually changed the fan to be actively controlled and not to go on and off with the compressor, which makes it possible to vent heat that has accumulated from the compressor heating up, and that makes a lot of difference. Not at the beginning when the machine is still cold, but after a while and it's been running, this actually makes a really good difference for getting the heat out of the machine itself, and it prolongs the time that you have between the compressor running, and that is something that I think is really good. And yeah, you can see the relay board, which is held in here with double-sided tape, and yeah, it works wonderfully. And I'm now gonna button it back up and test it. Okay, everything is buttoned back up, ready to go, I hope, and let's power it on. It seems to be alive. It's testing the solenoid, running up the fans, and it will start to cool now. So we're starting at 18 degrees, and the target temperature should be 16, I believe. And it looks like it's cooling. Now it's going to go through a whole cycle. Since it hasn't been on for a number of days now, this should take a while, and we can actually see how much overshoot it's going to have then, which is going to be interesting once I start optimizing the software. Takes a few seconds, well, or minutes to get going, which is normal. Since I can only display full degrees, this is actually, well, unavoidable. You don't really see that much. But if it's just going to stand here in the corner and do its job, I don't need absolute exactness. I just need it to work correctly. And I can always hook up a computer and get the cooling graph off of it. And as you can see, the new display looks a lot nicer. A lot nicer. And it nicely retains the look and feel of the machine. Only that you now don't have any buttons to set your temperatures. It all has to be done in software. But I'm going to add a menu so you can hook up your PC and configure the thermostat to exactly what you want. So any minute now it should be going into the second cooling phase with the bypass valve open. And here we go. And depending on the temperature of the evaporator coil, this phase may be over really quickly, or it may hold there for, I think, up to 1.5 minutes. And once it goes by the hysteresis value, it's going to just turn off the compressor, and it's going to operate the fan for another minute to cool down the compressor and the condenser. So now it's just running the fan, and in a minute the fan will be switching off, and then it'll go into idle mode, and it will just be monitoring the internal temperature. If that gets too warm, it's going to turn on the fan, or if the water gets too warm, it's going to turn on the cooling. And that was exactly what I wanted. And it's done. And it's nice and quiet now. Yeah, that was it. Yeah, it's working. So, thank you everybody for watching, and bye-bye.